x squared e to the y equals 3 sine x leads to this differential equation here. So let's verify that by differentiating term by term. So differentiating gives, so this is a product, so it's u. Dv dx, e to the something differentiates to e to the something multiplied by the something differentiated, plus v e to the y times du dx, which is just 2x, isn't it? It's just a simple power. The only thing that was awkward there was the e to the y. It's e to the something. Functional function in the v part, when you differentiate the dv dx, e to the something differentiated to e to the something multiplied by the something differentiated. So that's why we wrote that. So that's u dv plus v du is equal to, and then sine differentiates to cosine, so it's simply 3 cosine x. So that's one time through. Let's differentiate it again. So here, oh, this is awkward, isn't it? Because we've got three things, which are, not nice. No. Okay, so we've just differentiated this thing here. So if we take this as to be the u, then I already know that that du dx is what this is here. That would be du dx, wouldn't it? So bearing that in mind, because I've just differentiated that, this is the v. So let's go through this then. So differentiating, it's u e to the y times the v, which is y double dashed, plus v, which is y dashed, times du. Now, as we said, the du here is the same as that u was there. So that differentiated to all of this, didn't it? So I can put that in here without thinking about it too much. Y dashed plus 2x e to the y then. So there's our product for this term here differentiated. Now we just need to differentiate this, so it's plus u times the v dx, which is 2, plus v, 2x, times by u du dx, which is e to the something differentiates to e to the something multiplied by the something differentiated. So that's that product differentiated here. And then differentiate cosine, we get minus sine, don't we? Minus 3 sine x then. Minus 3 lots of, isn't it? With the minus at the front. Okay, so it's just a matter of tidying it up now, hopefully, and dividing by e to the y, and replacing the 3 sine x by this thing here. So let's do that then. I'm going to divide all the way through. No, I'm not. I'm just going to expand the brackets first. So what have we got here then? We've got x squared e to the y times y double dashed plus x squared e to the y here, and then it's going to be y dash squared, isn't it? Squared, that's that term there, plus 2x e to the y times y dashed plus 2e to the y plus 2x y dashed e to the y is equal to. So that's all the terms there. There was one term here, then there was 2 terms here and here, and then 2 more terms. So we had 5 terms in total on the left. Now minus 3 sine x, we can replace that. The minus can stay, but the 3 sine x can be replaced by x squared e to the y. So that's what we've got now. So let's turn our attention to this then. Let's divide by e to the y and try and tidy it up a bit. Gives, so we've got x squared y double dash then, and we've got y dash squared plus an x squared times y dashed squared. 2x and 2x y dashed make 4x y dashed. That's right, and the e to the y's go. Then we've got plus a 2, and then move this x squared over to become plus x squared equals 0. And in essence, that's what we wanted. Just need to swap around these two terms, but that's trivial, so we can leave it as done.